In Unit 5, Lesson 3, Section 3.2, Diagrams, Equations, and Descriptions, we are going to record answers to different questions on the next table or on the next page onto a table that's on the next page. So forgive me as I go through this. There's a bunch of pages, but we need to match each of these descriptions with a diagram. The descriptions that we're talking about are right here on this back side. So we're going to match these descriptions with these diagrams, and then we're going to write those descriptions, the marriage of those things, on this table right here where we see the diagrams. We'll also figure out what the equations are, and then we're going to do a little bit of work here. So let's get started with this first part. First off, a circumference C of a circle with a radius r. So we're talking about how do we find the equation, or how do we find the circumference of any circle. When we look down here at these diagrams, we need to look around and we need to figure out which of these would make sense. This one seems like it would make the most sense because we have a capital C and we have an R, and those are the same ones that I see right here. So this is diagram D. This is in fact the expression that's represented for how to find the circumference of any circle. We take twice the radius and then we multiply it by pi. For letter B, the distance in miles D that you would travel in T hours. Notice that we have, with this description, we have D and T as our variables. And as we look down here, we see letter B relates to that picture, that image. That's kind of cool. B is B. Then we look at the next one, the output when you triple the input and subtract 4. So we're going to triple the input and then we will subtract 4. So we're looking for a subtraction of 4. And we see that here in item letter C. That means that the following one, the last one right here, suggests that the volume of a cube, V, gives its edge length S. So we see V right here, and S, we know that this is letter A. So let's go ahead and record that information here on our table. Description A goes with diagram D. Description B has diagram B. Description C is diagram C. And then D is with A. Now we need to write an equation. To write this equation, what we need to think about is how we get our inputs and outputs. What we know about this is our output is our result. And so that result is, we would say that that S, being the independent variable, is going to be the piece that's put in. And then we get this outcome. So we can say that the volume is equal to the input S times itself 3 times. And so as we look at these, we're going to change each of these rules into equations by simply taking the output and writing it as equal to the rule. So the output equal to the rule all the way through. So when we look at this, figure D, the rule tells us that the circumference is equal to twice pi and the radius. Letter B, distance is equal to 60 times t, or the distance is equal to 60 miles per hour. Letter C, the output y is equal to 3 times the input minus 4. And then letter D, the description says that the volume of a cube V, so the volume, is equal to its side length cubed. All right, understanding these pieces and understanding what our input and our output is, we can use this information to be able to help us out. Once we're given a value here, to be able to find the output when the input is 5. So across the board, all of these inputs will have to be 5. So our input, when we talk about this, circumference is equal to twice the value of pi and the radius, which is our input, of 5. And now I just simply combine like term, or I combine through multiplication. 2 times 5 is 10. Circumference is equal to 10 times pi. If you were told to go ahead and simplify this, then you would say 10 times pi is approximately 31 4/10. If you're told to give an exact answer, you give that exact answer as 10 times pi, because pi is an irrational number. It never ends, it never repeats, and so we'd want to give it in its exact form. That's why it has a symbol. Next one, distance is equal to 60 miles per hour for 5 hours, meaning that our distance would be equal to 300. Our output is equal to 3 times our input minus 4, so y would be 11. And then our volume is equal to 5 raised to the 3rd power, so our volume would be 125 cubic units. There you go. So now the question is, what about independent variable and dependent variable? Well, the dependent variable is what comes as a result of multiplying and dividing and adding and subtracting. So it's an outcome. In this case, we would call this our output. That would make our independent variable the input. And so as we identify these, we have to think about which one depends on the other. So in this case, the circumference depends on the radius, and the distance depends on time, the output depends on the input, and the volume depends on the length of the side. So we could see right here, this would be R for the input, T for the input, X for the input, and side length for the input. That would make our output circumference, distance, the variable Y, and the volume. There you go. Make sure that we pay attention to these pieces and understand that a function describes a rule that will be able to represent an input and an output diagram. We can calculate what our outputs will be when we're given a specific input, and then determine the independent and dependent variables based on the relationship between the two variables. All right, ready for a little more? Coming in the next video.